Right. So remember, we are in the middle of software development tasks. So when we develop software, first we discuss the nature of software development. It's a complicated task. And also it's a project. And software is developed, not manufactured. Every time you are working in a new project, which is more challenging. And software development, you need different type of talents. So that is why you need a team. QA engineers, software engineers, database designers, sometimes UI developers, and so on. Okay. And also there's a big demand for software, especially when we develop software for businesses. So therefore we need to deliver fast. Okay. So those things we discuss. And then we moved on to what are the tasks in software development. Like tasks. Still we have not come to the methods. Still we are in tasks. So what are the major tasks? Planning. Actually, still we are in the planning stage. Requirement analysis, system design, system development, testing, deployment or implementation, evolution, maintenance, and reviews. Okay, so those are the tasks. So then we moved on to the first task, that is planning. Planning. So we subdivided planning task into subtasks. So this is where we start thinking about software development project and take those business decisions. So first of all, we need to understand the business problem or opportunity. We don't just start developing a system without any reason. So someone from some party will come up with this proposal. Maybe a manager, top management, maybe some other finding. So therefore, we need to first understand what is the business problem we want to solve, or what is the business opportunity we try to use and exploit. So what is the second task? Identify possible solutions. So once we have understood the problem or the opportunities, we must come up with solutions. Because every problem cannot be solved using software, information systems, right? So some problems we can solve using software, or maybe part of the solution is use of a software. So then we need to check the feasibility of the solution. So if it is related to developing a software, so our next task is check the feasibility of that solution. And we start discussing about that. Okay. Doability, practicality. So then we need to select how are we going to acquire it, if it is possible, feasible. And we moved on to that discussion also last time. And finally, we need to plan out for the future activities, depending on the acquisition options. So what are the tasks? Understand the business problem or the opportunity, identify possible solutions, check the feasibility of the solutions that you have identified, select the acquisition options, and plan the future activities based on your decisions. Right. So I told you that there are two reasons for. So there are two types of business things: business problems or business opportunities. We don't do things for fun. We always do something with some purpose, due to some reason. So especially in businesses, maybe we want to increase productivity, cut down the cost, increase customer satisfaction, increase our sales, expand our customer base, and so on. So those are the things that businesses really care. And those are the possible problems or the opportunities. So then we come up with solutions, how to solve that problem, maybe productivity issue, maybe customer satisfaction issue, maybe opportunity. There's a new opportunity with technology to go online and expand the customer base. There's a new opportunity to expand our business to a new area. Maybe in order to do that, we need some information systems as well. Okay, first look at it in business manner. So then maybe part of the solution is information system, complete new system or big change to the existing system or replacing all system. Okay. So therefore, don't think that developing a system is the only solution. Maybe that is part of it. Right. So remember then, so once you identify the problems and come up with possible solutions, still we are in the planning. We need to check the feasibility or the doability. So what are the areas we are interested? Technical feasibility, economic feasibility, operational, organizational, or sometimes we call it political feasibility, schedule feasibility. And there are a few more, but these are the things directly mentioned in your note, your syllabus. Right? So then you must know what is mean by technical feasibility, what is mean by economic feasibility, what is mean by technical feasibility. Whether the solution that you have proposed, is it technically possible to develop using the current technologies like Java, C Sharp, Python, React, Angular, JS. So these are the hot technologies these days. .NET framework. So can we develop? So that is why you need experienced tech leads, software architects. So they will take those decisions because they have the experience. So technically feasible. So then we need to check whether economically feasible. So economically feasible means number one, do we have enough money? So that is why you need to first do a cost estimation, budgeting. How much it will cost? Do we have enough money? Because otherwise you need to abandon it in the middle because you run out of money. Second part of economic feasibility is check whether benefits worth the cost. If the benefits are more than the cost only, organization will say, okay, let's go ahead and do it. Otherwise, it's economically not feasible. Economically, it's not worth. Right? So just understand these things, okay? Right. So technical feasibility, economic feasibility. What is the next one? Operational feasibility. So operational feasibility means, can we operate it in our organization? Because every organization has limited resources, tech, right, and so on. For example, if you are developing a system which need internet, do you have internet? Of course, these days, everywhere you have the internet, but maybe your branches are in very rural area. Right? Do you have the hardware resources? Do you have the employees who are competent to manage this? Operational feasibility. Hardware, internet, people, so that you can operate it. Because otherwise, after developing the system, so there are issues to operate your system. So then you have waste your time, money. And then we look at organizational feasibility, or sometimes we call it uh, political feasibility as well. Organizational feasibility means whether the organizational culture, that is pretty much employees' attitude and so on, will they accept this? Especially this is an issue in public sector, government. Sometimes government try to introduce a system to which the employees resist. Sometimes they even go into picketing, right? Strikes, saying opposing the introduction of the system. Okay, right. So remember what are the tasks in planning? Identify the business problems, come up with possible solutions, check the feasibility of those solutions. That is what we just discussed. The fourth one is, now you have checked the feasibility and you are confident that yes, maybe some of the solutions or one of the solution is feasible. So now you need to think about the acquisition options. because now you have a solution or one or two which are feasible, reasonably feasible, technically, operationally, organizational, economic. Now you need to think about what is the best way to acquire it, get it. Okay, so there are different ways you can get a software. So what are the two major approaches? Buy off-the-shelf software, build, not build, actually there's a spelling mistake, build custom software. Okay. So off-the-shelf software means you buy a common software like accounting package, inventory management system, common ERP, ready-made software. It's like buying a ready-made garment. Go to a shop and buy a ready-made garment. You can do it fast. You can do it fast because it's readily available. Right? Because it is readily available. Okay. And also usually the cost is also low because it is not only you use it, some other customers are also using. So therefore the cost is shared. And quickly you can get it because software is already developed. Okay. But there are challenges like it may not 100% fit into your requirements. That is the biggest issue. Maybe there are limitations in support, customization. So less flexible when you buy off the shelf software. Okay. But if it's typical system like accounting system where you don't need to do a lot of changes, or if you are a small business where you can't afford to develop a system for you, like small shop, small uh, pharmacy or something. So better option is anyway go for buy off the shelf software. So how do you go for off the shelf software? Because if possible, this is the cheapest. This is the fastest. Obviously, you need to identify the requirements. Without identifying requirements, you can buy a software. Okay. So first, in detail, understand the requirements. Then find out what are the potential off-the-shelf software packages available for these requirements. For example, if it is accounting software, maybe dozens of accounting software available with different features, different cost. So then identify gaps between your requirements and available functionalities from these packages. Right? So your requirements and the available functionalities. So then you need to pick the software with, okay, just give me 1 minute. Right, sorry. So now you need to pick the best packages, best off the shelf software that is matching with your requirements. Still, there can be gaps, but the least gaps. Which software has the least gaps? And also you need to think about the cost and other things. And when you select the best software, still you might be able to get some customization depending on the software. Some vendors, they provide limited customization, limited support. So that customization means some changes for your requirements. If possible, you need to get it done. So that is the approach if you go for buy off the shelf software. Right? What are the steps? Detail, identify your requirements, identify or pick some potential off the shelf software packages, identify gaps between your requirements and available functionalities, select the best out of those, having the least gaps, and of course you need to consider other factors like cost. And if possible, get some customization so that you reduce the gaps. But anyway, you will not be able to get ideal software because this is not something built for you. So you need to find the near ideal software, the most suitable software. So I already explained you the process and cons. This is the least costly. This is the least costly because the software is not only used by you. So therefore, the software vendors will, in general, sell it at a lower price. Fast to acquire because the software is already available. Maybe within 1 day you can set up if you don't need to do a lot of customizations. So those are the biggest advantages. But the biggest disadvantages are because it is not something developed for you. It's a common software. It may not 100% fit into your requirement. Just like you go and buy a ready-made garment, it may not 100% fit. And limited customizations because they have so many customers. And you don't get a unique advantage because this software is not uniquely developed for you. It's a common software. When you get that software, your competitors can also get the software. So that means you are not getting the competitive advantage because your competitors are also using the same software. But anyway, it's not a big issue in some areas, like typical solutions. Okay. Right. Any questions? This is very easy subject, but you must be now serious. Business mindset. And this is a very small topic. So within another 2 or 3 days, we can completely finish. This is not like networking. No, this won't take much time. Right. So what is the second option? If you don't go for the build or the off the shelf or packages, you need to build custom software. Custom means maybe you have seen this word in tailor shops, custom tailors. So custom tailors means they tailor for you your specific needs. Ready-made garments, custom tailors. So custom software means software which is custom for you, specifically developed for you, your requirements. And the biggest advantage is if you do it properly, you will get 100% fit into your requirements. And also you can get competitive advantage because you have a unique solution which is tailor-made for you, your requirements, optimized for your requirements. Obvious disadvantages are it will be more costly because you need to bear the entire cost and it will take time because you need to wait until the software is developed. Maybe 6 months, 1 year. Okay. Right. When it comes to build a custom software as opposed to the off the shelf, you have two options. That is insourcing and outsourcing. So insourcing means sometimes we call it in-house development. You develop it in your organization. The software that you need is developed in your organization. For that, you need your own software development teams and so on. Other one is outsourcing. You give that responsibility to a third-party software development company. Okay. So insourcing is rarely used these days because most of the time business organization, they don't keep software development teams because it's a very costly thing. But there are some big companies, they have their own IT departments. Of course, almost every company has their own IT department, but very rarely they have their own development teams in the IT department. Mostly IT departments do the supporting, network administration, database administration, not software development. But if you want to go into this approach, you need to have your own software development team, which is very rare, but there are situations like big business organizations, some banks, they have their own software development teams. In that case, they can do it. Okay. So the advantages, the main advantage is you are in 100% control because you develop it, your team members develop it. But the disadvantage is obviously you need dedicated internal software development team, which is not practical in most cases. Right? Very rarely we use this approach. But anyway, very rarely, anyway, we use it in certain organizations. And you get all the advantages like unique competitive advantage, 100% fit into your requirements if you develop it properly. And here you are in 100% control because your team members develop this. So second option for custom software is outsourcing. You must be familiar with this word outsourcing. Outsource means get it done by a third party. So there are plenty of software development companies. So you can get into a contract with them and let them develop the system. But that system is developed specifically for you, specifically for your requirement. And the advantage is when you outsource, usually they have the best expertise because they are experts in software development. And also, then the customer, they can concentrate on their core business. Right? If it is supermarket chain, they must concentrate on selling products, not software development. So then you give that responsibility to the third party and help them, collaborate with them, and you concentrate on your business. So the disadvantage is if you go for outsourcing rather than insourcing, obviously you need lost a little bit of control, which is not a big issue in most of the cases because now third party is developing the system. Most of the time that is not a big issue, but anyway, if someone asks in the exams, uh, in-source versus outsource, what are the disadvantages? You can say we have a little bit of less control if you go for outsourcing compared to in-source. And if you have so much concern about security, confidentiality, sometimes in-sourcing is better option. That is why some banks, they like to get some systems done by their internal teams. Right, any questions? So that's the end of the stop task one, software development task one. What is that? Planning. Understand the business requirement, understand the business problem or opportunity, come up with some possible solutions, check the feasibility of possible solutions, decide on the acquisition options. Okay. So that is what we discuss. So now we are moving to the second task, requirement analysis. Whether it's built-in software package, custom software, in-house or outsource, you need to do a detailed requirement analysis. So requirement analysis means understand the requirements in detail. Okay. So these are the 5 tasks in requirement analysis tasks or the second task in software development. Gather, analyze, model, document, verify. Actually, your second paper question is based on this. Almost every year you get a question in system analysis and design, second paper question. Usually easy question as well. So that question is 100%, almost 100%, sometimes 80% based on this. Model in the requirement. The data flow diagram, context diagram. Okay, so therefore we are now seriously into this topic. Right? So this is the task 2, planning, requirement analysis. So what are the subtasks? Gather requirement, analyze requirement, model requirement, document requirement, verify requirement. So then only we move on to the design. So let's take one by one. Gather requirements. Gather requirements means what? Collect the requirements. Right? It doesn't matter whether you go for off-the-shelf software or software package or custom software, you need to gather requirements. Maybe you're planning to acquire a accounting system, inventory management system, ERP system. Those are huge systems. And if you outsource it, you need to help the other team in this task. But if you want to buy off the shelf or insourcing, you need to do this. But outsourcing, usually the other company, software development company will do it. You need to help them. So how do you do this? Gather requirements. So then someone might ask, okay, if we are developing it, do we need to gather requirements? Yes. Because the requirement, remember, software is a conceptual thing and it has so many business aspects. Maybe you need to talk to some business managers, low-level operators, sometimes even customers to get their expectation, to get their requirements. Right? So therefore, depending on from whom you want to gather the requirements, because you need to discuss, meet different type of people, top management people, non-management people, sometimes domain experts. For example, if you are developing accounting system, so you need to get the help of uh, experts in accounting. Maybe your organization has that kind of people, like accountant, or you need to consult an external person. Right. So how do you gather requirements? Gather requirements means collecting the requirements from your managers, other operators, sometimes even from your customers. So we can have common meetings. So all the relevant parties or some of the relevant parties get together and discuss the requirements and document. And this is very good approach because if there are any conflicting requirements, doubts, when all the parties or most of the parties are there, it's very easy to discuss those things and resolve. Otherwise, you need to go to this person, that person separate. We can have individual interviews. If we find it difficult to get everyone into the meetings, maybe with others, we can do some interviews, discuss, gather requirements from individuals. But if you want to get some opinions and gather requirements from multiple people, we can send them questionnaires. Questionnaires means something like questions and ask them to answer. Sometimes yes, no answers, MCQ answers, or small, simple descriptions. Write the answers. Especially when we need to get the requirements from large number of people and get their feelings, get their objectives. So this is a good option. Another approach is observe how the business is happening right now. Say we are developing like sales management system. So go and see how the sales is happening right now. Okay. So then you can understand the requirements better. Who is doing the sales, who is doing the approval. So then you know that, okay, these are functionalities must be separated. And also if they already use a system, maybe they are already using accounting system. Maybe they're already using inventory management system. So see how it is developed. What are the functionalities available? Maybe some of the functionalities you also need. Likewise, there are so many ways, depending on your requirements, you will pick and choose some of these, like common meetings, interviews, questionnaires, observe, analyze the existing systems and their documentation and so on to gather requirements. Okay. Right. So that is the first task in requirement analysis. What is the next one? Analyze. Remember, your second paper question is from here, but anyway, we don't cover that today. The data flow diagrams and so on, but it's part of modeling. Okay. Right. Analyze requirement. So that is our second task under requirement analysis. So what is people analyzing requirements? Analyze. විශ්ලේෂණය කරනවා. For example, before a particular cricket match starts, or even in the lunch hour, maybe sometime after the match. So there are some experts who analyze the situation. So that is analysis. Now these days there are a lot of political analysts who analyze what is going to happen in this election. So that is called analysis. Analyze. So similarly, when we gather requirements, we need to analyze the requirements. So what is mean by analyzing requirements? So analyzing anything. So first we need to look at the big picture. That is the number one. The big picture, overall understanding of the requirement. What do we want to develop? What are the high level functionalities? So then we can analyze different aspects separately, like data related things, data processing related things. So that is how we do it in structured system analysis and design. In your syllabus, what we do is structured system analysis and design, not object oriented. Structured analysis and design, we look at the data separately and business process separately when we analyze and model. For example, data-related analysis is pretty much ER diagrams. We cover it in database subject. And process-related analysis and modeling is pretty much context diagrams, data flow diagrams. That is something we do in this subject, this topic. Not today, definitely next class. This is something we cover in our next topic, database. Right. So what are the tasks? Gather requirement, analyze requirement, model and document. So model and document we don't cover here because we are going to do it in our next subtopic. Right. You will get a separate note for that. Actually, that note is also uploaded to the Google Classroom. That will be your last note for this subject. And so therefore, we will look at how to model your data, ER diagrams, process, context diagrams, data flow diagrams, level 1 DFD, level 2 DFD in that session. Okay. Right. So now gather requirements, analyze requirements, model and document requirements. Basically, document means those models that we will discuss later. And the final task on the requirement analysis is now we have document the models, document the requirements. We want to verify the requirements. Verify means we want to show the requirements. If it is done by software development team or your IT department team, again, this is our understanding of the requirements. Because we gather it from other managers, users, operators, and so on. So they are more familiar with the requirement. So therefore, we get it from them, and our understanding, according to our understanding, of course, we can do some clarification. We have documented, model it. Now, we can't straight away go to designing and development. So now we need to verify our understanding, check whether our models, our documents, that is different models based on our understanding of the requirements like ER diagrams, context diagrams, data flow diagrams. We need to show it to the customer or the relevant people and verify. Verify means they must say, yes, correct. This is what we need. That is why when we model requirements, we use very simple approach so that anyone can understand. Manager. There must not be someone who has done ICT. So we keep the modeling very simple, like data flow diagrams, ER diagrams. Right. So once they say yes, or they will give you some feedback saying, no, this is not correct. It must be like this. So then we can update the models or documents. Or they will say there are missing things. Or they will say, no, this is not required. We can remove it. So likewise, so these are very, very important. So we are discussing practically how the software is developed. planning, requirement analysis. What is the final task in requirement analysis? Verify requirements. Right. So any questions? So I try to do it faster because this is a theory subject. This is not like subnetting, normalization of databases, programming, where you need to think a lot. Here also you need to think, but here you need to think practically, especially business mindset, how the things happen in real world. Okay. Right, still we are in the second task, requirement analysis. First task is planning, okay? So we can identify two types of requirements. Two types of requirements. So this is a very famous question. Frequently you get a question, they will give you a scenario and say which of these are functional requirements, which of these are non-functional requirements. So what are the two types of requirements? Functional requirements, non-functional requirements. So functional requirements are functionalities of the system. Okay. For example, if it is employee management system, maybe functionalities are capturing the employees check into the company. That is why they have fingerprint scanners and so on. Check out, apply for leaves, maybe payroll, that is salary calculation. So those are the expected functionalities. Functionalities. If there are some screens and so on, and if we process it, so it's a functional requirement. Functional requirements. So most of the requirements are functional requirements. This functionality, that functionality, and so on. And it depends on which type of a domain or business area your system belongs to. Right? It is supermarket. Is it education institute? Is it a hotel chain? Is it a private hospital? So requirements might be different, but you should be able to identify the requirements. Think about this. So each year you get a scenario, case study. So you need to read the case study and draw the diagrams. Okay. Identify the functionalities. Right, so those are called what? Functional requirements. Say we are developing a system for a private institute to manage students. Can someone tell me what can be the possible functional requirements? Just typical. It's a student management system for a private institute. Say they are conducting different classes, courses. Anyone? Because in the exams you need to think.
Student details.
Yeah, enter student details. Or we may say something like, what is the first, usually what is the first functionality? Functionality. Functionality means little bit you need to think little bit more high level. What is the first interaction students do with our system or with the institute? That is inquiries. Inquire about different courses, course details, payment structure, class dates. So that is inquiry handling. So likewise, you need to think seriously, right? So now can you give me another functionality after inquiry? If it is a successful inquiry, what will be the next functionality? Anyone? Now we have given the details. The institute has given the details. Maybe the student is happy. What can be another functionality? Maybe you don't have the exact words, but yes, we will build those terminology. Register for the classes, right? Register. student registration. Okay. Then time to time make payments, maybe installments and so on. And maybe attendance management if they're interested. If they're conducting exams and so on, maybe exam related. So these are all what? Possible functionalities. Okay, possible function. If it is supermarket or something, make orders, cancel order, okay, make payments. Maybe you need to do some purchasing. Those are the requirements, functional requirements. Okay. It's very important that you understand what is functional requirements. So the second category is, so these are some typical functionalities for sales order management system, like Singer, soft logic stores. This is for student management system. So that is just to give you, make you a little bit more familiar with these things. Okay. Of course, you may come up with some other functionalities. This is not a complete list. It depends on the real requirements. Right. So next we have the non-functional requirements. So the word is little bit misleading. So therefore, don't go by the words. Because if you go by the words, you may feel like requirements which are not functionalities. Okay, in a way it is correct also. So non-functional requirements are requirements, but those are not specific functionalities. Okay, but these requirements are important to proper use of the system, practical use of the system. Or these functionalities are required for the long-term maintenance of the system, proper use of the system, long-term maintenance of the system. But these are not direct functionalities. But at the end, we need these also. Otherwise, practically, we will not use it. So performance, if the system is very slow, when you submit, it takes about 30 seconds to get a response. So that is not good. So therefore, maybe they have non-functional requirements says every screen, when you submit, you must get the result within maybe 10 seconds. Performance. A particular report must be generated within 30 seconds. Security aspects. User friendliness. How user friendly the system is. Otherwise, people will not use it. Those are not functionalities, but those are also important. Those are not functional requirements. But those are also important for the success of the system. Therefore, those are also requirements, non-functional requirements. And then the maintenance related things like maintainability, how easy to maintain, change, interoperability, can we use it with other systems? Because maybe you need to interact with the bank. Upgradability, can we upgrade this with new technologies? Can we upgrade our system into different version or newer version of the database, newer version of the programming language, .NET framework, a newer version of operating system. So those are not functionalities, but whether we can do it or not is important. And those are called non-functional requirements: security, performance, user friendliness from proper use, long-term maintenance, maintainability, interoperability, upgradability, and so on. So these are super, super important for your exams as well, okay? Right, so let's do one past paper question about these requirements, okay? Right, so this is such a question. So its first question is, what is requirement analysis? Now you must have an answer for that. What is requirement analysis? Requirement analysis is basically gather analyze, model, document, and verify requirements. So then you can little bit more explain about analysis because it's second paper question. Okay, it's a second paper part B. That means you get enough space. You get actually whatever the amount of paper you want. So then you can explain a little bit more about the analysis because remember gather, analyze. In general, you call it requirement analysis. Gather, analyze, model, document, verify. So then you take a little bit more details about analysis. See the big picture, classify them, categorize them, and see how these requirements are interrelated. So that is what analysis is, and possibly model it. Okay. Right. List two advantages of requirement analysis. So what are the advantages? So you can answer these questions if you are really serious about your subject. Why do we need this? And gather requirements, like analyze it, model it, like ER diagrams, data flow diagrams, context diagrams, makes get them into documents and verify it with the customer. Why? What are the advantages? It's a just list, you don't need to explain. So one is what? We get a proper understanding about the requirements because we are doing analysis and modeling. So when we do these things, there's a big chance that our understanding is getting better and better. So many points you can mention, right? Another advantage is we can document the requirements formally so that everyone agree these are the functionalities. Otherwise, at the end, there can be some conflicts. But now we have a document. Everyone has agreed. That is why we verify the document also. Okay. And also during the requirement analysis, if there are any ambiguous requirements, if there are conflicting requirements, right? So these things come to the surface and we can resolve those. So likewise, there are so many practical usages. That is why we do this. Right. So let's do the third one. Right. Sorry. Give one method that can be used to verify whether functional requirement is satisfied in the system. So that is not verifying requirement. That is functional requirements is satisfied in the system. That means after developing. So don't get confused because this is now initially you have identified the requirements, functional and non-functional. Now maybe you have developed it. Now this question says give one method that can be used to verify whether a functional requirement is satisfied in a system. Can someone come up with the answer for this? Use your common sense. Just use your common sense and tell me. Still, we have not done it because this is a different task later on. Just use your common sense. How do you verify that a particular requirement is satisfied in the developed system?
Implement the system.
Implement the system means not to verify. This says verify. That is check whether it is properly implemented. So how do you check whether it is properly implemented? That is one of the tasks in software development. Anyway, we have not done it yet. How do you call that task? Remember, planning, requirement analysis, software design, development, testing, deployment, maintenance. So which task is doing this particular thing?
Testing.
Testing, obviously testing. So therefore, once you do the testing as a task, this question is super simple question. Right? This obvious answer is testing. Okay. Right. So now we'll move on to the fourth one. The following list consists of some functional, non-functional, and other requirements. So they have even got to get into third category also, other. Right. So that means you can't put it into functional or non-functional. So then you can take it as other. So that means it is not a functionality. It is not a something help better using the system or maintainability. So completely something else. So then you put it into other, because there can be such function requirements. But usually most of the time requirements will belong to either functional or non-functional. Right. Of a proposed school library management system where users can borrow and return books in addition to other usual tasks. So there are some usual tasks in the library, like people go and read books and so on. Other than that, so the students or the users can borrow books and return books. Right. So that is big, that is overview of the system. Right. So now you need to say whether these are functional requirements, non-functional or other. Right. Take 2 minutes, because you just need to say functional or non-functional. Okay. Just functional, non-functional or other. FNFO. Right. Do it. Take 2 minutes, 2 to 3 minutes. Just take 2 to 3 minutes, and because these questions are very easy. Okay. So let's continue. Right, first one. The system should authenticate users through username and password. Is it a functionality or not a functional or non-functional? Sometimes you need a little bit of experience, because sometimes it can, you might be wondering. So that is why we want to do a few questions. And there can be maybe one or some scenarios where sometimes it's debatable. Sometimes we can't agree with, sometimes I can't agree with the examiner, but anyway, that is part and parcel of our life. What do you think? The system should authenticate users through username and password. How do you feel about it? Is it a functionality or non-functional or something else?
Others.
Sorry?
Others.
Other. Why do you say it's other? Okay, you don't need to give reasons in the exams. But I feel like it's a functionality, because you can see when you go to a system, so there's a login screen where users need to enter the username and password and submit. Right? If you can see screens and blah, 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 that is for functionality, usual. But at the same time, this is non-functional requirement as well, because security, this is something to do with security. And only the authenticated users can access. Therefore, this is related to non-functional requirement as well. But because they are talking about through username and password and blah, 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 I'll go for it as a functionality. Okay. Anyway, let's double check with the marking scheme answer, because this can be debatable. Okay. I say it's functional. Right. Second one. This is now this obviously a little bit difficult question. Actually, it's not difficult. It's a little bit fussy. Fussy means doesn't mean difficult. Sometimes that is part and parcel of life. Right. B. The system should enable users to search for books based on title, type, ISBN number, publisher name, and so on. What do you think? Is it a functionality or not a functionality? That is clearly a search functionality, right? So that is search functionality. Let me go and do some search. The total cost for the library system should be less than 500,000. Is it a functional requirement, non-functional requirement, or other requirement?
Other requirements.
Yes, so that is other requirement. This is because it is not related to functionality. It is not related to like maintainability, blah, 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 or quality attributes like user friendliness, uh, performance, and so on. So this is more management decision, management, budgeting. So therefore, I'll go for other. The system should be available 99% of the total time. Available means up and running. That is a,
Functional.
it is not a functionality. Functionality means very specific thing, like log into the system, do a search, make an order. This is not like that. This says 99% of the time system must be up. It's about reliability. So it is a non-functional requirement. It's quality attribute. It's not a specific functionality. The system development should be completed within 9 months. What type of requirement? That is
Others.
that is also other, right? It's more management, right? Process related thing. Book length in detail should be preserved even if the system crash during operation. So even though the system crashed in the operation, um, the booklet in detail must be available. That means in the database or whatever. So it's again a little bit confusing, but definitely it's not other, right? So it's,
Functional.
yeah, is it a functional? Or, actually, I am also confused. Book lending detail should be preserved. I think this is more into the reliability of the system, because this is not, they are talking about a functionality. If they don't use this particular part, system crash during the operation, I'll go for it as a functionality. But because it says, even if the system crash during the operation, I'll go for, it's more reliability, like user friendliness, reliability, maintainability, I'll go for non-functional. But anyway, let's see. Maybe my answer is wrong. Answer is wrong means those are fuzzy things, opinion. And the book database of the school library management system must be secured by preserving unauthorized access. The book database of the school library management system must be secured by preventing unauthorized access. So is it a functional or non-functional? No other. I know this is challenging for you guys. So if you see some screens and so on and people go and directly use it, it's a functional requirement. But this is not something users can go and do something. Rather, this is something we configure in the system. Right? But here I took it as a functional requirement because you can see login screen and so on. But this is something we do internally by logic, but users, they don't directly get into this. So therefore, I go for non-functional requirement. Again, might be debatable. You can see this question is really fussy. I wouldn't say difficult, fussy. Right. Since the Past Pupils Association has indicated its willingness to develop the system, preference will be given to them. What kind of requirement is that? So that is again related to management, right? So therefore, I'll go for other. This is management decision. Who should develop it? Nothing to do with the functionalities or non-functional, right? So let's see. Maybe sometimes my one or two of my answers are also not correct. Correct in the sense those are debatable. Okay, so that is a little bit of negative point of doing this kind of question, right? But if you do something like programming question, logic questions, you don't get into this kind of fussiness, right? Right. So let's see the answers from the marking scheme 2019 paper 2. So that is 2021. CQs. Paper. Right answers. Question is that. Question Second paper, 6. Question 6, second paper. D. It's a second paper B. That is why the question answers are fuzzy. That is 6. Right. So these are the any one form point. That is what is requirement analysis. Analysis finding the requirements of the information system before its development, finding the functional. So whatever. So if you have at least one of these answers, right, anyone, but you try to give a little bit more details, right? Studying and analyzing the user needs, analyzing the requirements of the proposed system, but you try to give a little bit more details, okay? Right. So the advantages, right? So remember the previous one answer is testing. Another name for testing is validation, no verification. Right. So this one. The functional requirements are A and B. Okay. A and B. So let's see A and B. Right. A and B are functional. There's no other functional. Okay. So A and B are functional. So that means those two are correct. So then non-functional requirements, any two from DFG. DFG. So D, yes, non-functional. F, non-functional. G. If you have mark any two also, you get the full mark because this is fuzzy. Okay. And obviously then the others must be other, right? So they have not even mentioned about the other. For specifying functional and non-functional, they have given the full marks. Okay. I don't know why they have not marked other, but obviously if it is other than A, B, D, F, G, that those must be other. Right. So in our case, yes, H is other, E is other, C is other. But for some reason, they have not given marks for those things. Right. Anyway, I don't know why. Right. So we can see, so because the answers are a little bit fuzzy, examiner has done a sensible thing. If any two of those are correct, you get the full marks. So that means even though you mark maybe G as functional, because these two are correct, you get the full marks. Because these are a little bit fuzzy answers. Okay. Right. Any questions? Because so this is super important topic, okay, and easy, but you need to be very serious. Right. So that is, now we have discussed two tasks: planning, requirement analysis. But we will revisit requirement analysis modeling part in our next note or next topic. Okay. And I have uploaded that note also to the Google Classroom. Right. So now we are moving to the system design. Okay. System design. So remember, when we are developing complex systems, you can't straight away develop. You design and develop. So that is why we need engineers. Engineers design and develop. So engineers are required when systems are complex. So this is not hello world application. This is not something that print 1 to 10. Right. So in designing phase, that is something we do before development. We come up with some solutions or propose solutions. Now these solutions are technical solutions. How the solution is developed, right? Not uh, picking which solution to do. And pick the best solution out of those. Basically, when we say best solutions, it's different architectures. Should we develop it in this way, that way, at high level? Should it be a web-based developed application? Shall we develop it as a component-based or standalone? And then we need to model the solution, just like model the requirements using ER diagrams, data flow diagrams. We can model the solution also. Okay. like logical ER diagrams for database and so on, and refine the solution with some more discussions internally. We can refine and come up with the best design. Okay, so we can subdivide designing into two levels. So this is directly mentioned in your syllabus. So designing, the early part of the designing is called logical design. The latter part of the designing is called physical design. Okay, logical design, physical design. So logical design means conceptual design, which is not, we are not yet committed to a technology. We are not committed to whether to use .NET, Python, C Sharp, but using the normal concepts. We have not committed whether to go from MySQL, Oracle for database. We have not committed to whether it's PHP or with ASP, JSP, but we can still come up with designing, general design. So that is called logical design. It's a technology neutral design. Still, we have not fully committed to a particular technology, but those technologies have common features. Okay. So then we select the technologies. Actually, we select the technologies after logical design. So after logical design, we need to select which technology is best suitable for this logical design, or which combinations of technologies. Once you decide, okay, let's use MySQL database. Let's use Python for program flows UI. Let's use Java. Now we can go for physical design. So don't think that physical design is something physical, tangible, because software is not tangible. So here physical means detail or technical specific, technology specific design. So this is more closer to the development. This doesn't mean this is the development, but we are getting closer to development because now we have decided the technologies as well. Right? So we can refine it because different technologies have slightly different ways of doing things. So you need to refine your design. So if you have any questions, you need to ask because these are very easy topics, but maybe you have questions, doubts. So you need to clarify them then and there. Okay. Fine. Logical design, physical design. Remember analysis, we had high level analysis and detail analysis. Right? Overview analysis, overview modeling, detail modeling, like context diagram, data flow diagram. But here, logical design, physical design, that is requirement. This is solution. Design, when we say design, it's something to do with solution. When they, earlier it was understanding requirement and modeling requirement, verifying requirement. Okay. So these are some differences between logical design and physical design. So logical design is more logical or conceptual or abstract. So we do it at abstract level, conceptual level, without committing to a technology. But physical design is more technological. Now we are more specific to a particular technology. That is after logical design. Actually, we refine this. It's not a big thing. Just refine this depending on the technology, because different technologies support different additional features. Maybe we can use it. So specificity. This is not very specific. This is a general solution because still we haven't decided the technology as well. But this is more specific, specific to a particular technology. For example, later when you are doing database, actually database is our next subject. You will learn there's something called ER diagram. ER diagrams we use in analysis, then we use it in logical design, and then we refine the ER diagram, that is physical design. So refine it according to the features of the technologies like MySQL technologies and so on, and performance and so on. So logical design we do early, technology neutral, conceptual. Physical design we do next after logical design, after deciding the technologies. It's technology specific. Okay. So you need to think. You can't just read this and memorize. Think. If you have any questions, clarifications, ask. Okay. Right. What are the system design tasks? Remember we discussed what are the planning tasks, what are the analysis tasks. Now we are into what are the design tasks in general. In general, of course, the two tasks are logical design and physical design that we know. Early stage is logical design, later stage is physical design. But we can identify subtasks in designing. So the first subtask is do the overall designing, or we call it system architecture. You need to figure out what is the architecture we use: client server, peer-to-peer, standalone. So when you are doing web development and so on, you will be better, more and more familiar with these terms. For example, web applications are client server. Okay. So using Python, you can develop standalone applications. Likewise, you need to decide which kind of application, or what is your overall design architecture, system architecture. Then you can go into the detailed designing of different aspects: UI design, database design, program design, integration design, and so on, based on the architecture. Okay, based on the architecture. So I try to make this not as simple as possible. Actually, that is what I did last week. I took out a lot of additional details and try to keep it very minimal, essential, because otherwise you will find it difficult to remember, right? A lot of things are there. So I try to make it up to the point. Right. As I told you, there are popular system architectures that you need to decide early. Of course, not you guys, uh, experienced software designers. Standalone architecture, you will understand what is standalone architecture when you do Python programming. Then client server architecture, you will understand that web applications are client server. There are peer-to-peer network related architectures, layered architectures. So likewise, you need to decide the architecture. So don't worry, they will not ask which architecture is best for a particular thing, but just remember that is part of the designing, right? Overall design or deciding the architecture. Then you can go to the detail or different aspects and do designing. Okay. So don't worry too much about these things, right? Standalone architecture, client server. You will learn about these things, especially in web development. Right? For example, your browser is a client and you are served by the web server, like your PHP code will be run here, but your JavaScript, HTML, CSS will be run here. So don't worry, you will be more and more familiar with these things when we do web applications, email, file transfer, those are client server. Then there's something called peer-to-peer. Again, don't worry. We will learn about those things when we do web development. Okay, so peers are pretty much, they're equal level. Client server means two different roles. Client can request and consume. Server can only response. But peers can both request and response. So this is how cryptocurrencies, torrent-like applications are developed. Right. You will learn about these things more in web development. But just remember, those are some possible architectures: client server, peer-to-peer, standalone. Okay. So then you can go into detailed designing different aspects. So one such aspect is designing the user interfaces or user experience, UX, UI, user interface. Database design. So that is something you learn in your next topic, database. Program design, that is flow charts and so on, that you will be learning in programming subject. Break it into modules and so on. So these are things that you will be learning in the future in A-level ICT. But so what are the design related tasks? One classification is logical design versus physical design, technology neutral versus technology specific. So then another way of classifying is overall architecture, then detailed design of UI or UX, database, program, integration, and so on. So UX design or user experience or user interface design, that is design in the user experience or user interfaces. That is very important because remember, one of the non-functional requirement is what? Usability, user friendliness, ease of use. So when you go to ATM machine, when you use a particular payment system, if it is user friendly, you will easily, because you don't get training and so on, right? So you use it and learn it. While using, you learn it. So therefore, it must be very intuitive, practical, natural, so that people can use the common sense and using it. So therefore, the designer must know what are those common conventions and so on. So that is called user experience design or user interface design. So good user experience design will result in user friendliness. That is consistent, simple, familiarity. Familiarity means in the user experience, UI design, we use things which the users are already familiar. For example, if you have to select one of the two, you must go for radio button. Don't go for checkbox, because checkbox, they think of multiple selection is allowed. So likewise. So if it is positive thing, use something like green color. Negative thing, use red color. So the moment they see red, they know that something wrong. But don't use red color to say positive things. So that is what is meant by follow conventions, consistency, familiarity, because people familiar with green color for positive things, red color for negative things. I mean, if you need to, if you need the user to click on that, make it something like a button, because people are familiar with pushing a button, clicking a button, rather than clicking a text. So there are a lot of concepts in user experience design: consistency, simplicity, familiarity. Right? Have a proper theme, and the final objective is make it user friendly. Right? User friendly. People use it with ease. People don't make mistakes. But end users don't make mistakes. End users doesn't get frustrated. Right? Database design. So we don't want to talk much about database design because that is one of the big topic in our next subject, database. Right? There's something called logical database design, physical database design, right? With some ER diagrams. Don't worry, we will be discussing it there. Okay. Then the program designs. Break it into modules and design the logic of each and every module, functionality, flow charts, pseudocode, modular diagrams. Again, don't worry too much about these things because these things we cover in programming subject. So there's something called structured designing, object-oriented designing, So we are pretty much interested in structured design in A-level ICT. So just familiar more and more with these concepts, okay? Because these things are interrelated with in other topics. Right. Any questions up to this point? Planning, requirement analysis, design. Check the time. We have more time. Therefore, let's move to development as well. So if I'm going too fast, just let me know because I'm going actually fast. I'm going fast, assuming that you guys are okay with this because no one is complaining saying that it's too fast. Okay. Right. So planning, analysis, design, another task is develop. Your design cannot be executed, right? Your developed software programs can be executed. Your ER diagram is not your database. Database you need to set up using SQL and so on. That is called system development. And develop the system based on the design. Based on the design. You need to develop the UI, develop the database, develop the business flows, like different functionalities. Inquiry handling is say it's a student management system. Inquiry handling, functionality, you will do the registration of the student, do the payment, developing those business flows or functional flows. And sometimes you need to integrate with other systems for payment and so on. Those are all part of development. You need to develop the user interfaces, database, business flows, and integrations. In a small system, maybe the same set of developers will do all this. But in a very big system, sometimes we have specialized user experience, UI designers and UI developers, specialized database designers and developers, specialized backend developers, and so on as well. And sometimes we have even specialized engineers for integrations. But most of the time in a small system teams, so developers need to do all these things. Right. So the next task is testing. Development, we don't talk much because so that is covered in database subject, database development, and program development that is in programming. And of course, we are not interested much for the UI development in your A-level ICT. Because we will be developing only command line applications, not graphical user UI applications. A little bit of UI we do in web, HTML, not little bit, a lot of things like HTML, CSS, JavaScript, how to develop web user interfaces. That is why this development topic is very small, right? Because development is done in other topics, web development, database, programming. But you must know the tasks. UI development, developing the database, developing the functional or business flows, and integrate with other systems. Right. So next task is testing. So why do we test? To verify if the functionalities are implemented according to the requirements. Like verify, validate. Right. Testing is the process of evaluating or verification of systems or its components to determine whether it meets the requirements. Okay. Or whether the functionalities are properly implemented. So testing is collaborative effort. Some of the initial testing is done by developers like unit testing, integration testing. Then QA engineers involved in or testers involved in system testing. And finally, the end users, so the customer side people, they do the user acceptance testing, UAT. So therefore, developers involved, QA people involved, and even the end users or the customer involved in some testing. So we can subdivide testing into two categories. This is a different classification. That is glass box testing and black box testing. Sometimes the glass box testing is called white box testing, but this is the better word. So glass means you can see internal things, transparent. Black box means you can't see the internal things. Still, without seeing the internal things, without thinking about the internal things, still you test. So as I already mentioned, glass box or white box testing, test the system with the awareness or visibility of the design and code or the development. So usually this is done by developers because developers have that visibility because they are the one who develop it. They know that there's if condition, else condition, there's a loop. So now they want to test whether those things are properly developed. Those are called glass box or white box testing, mostly done by developers. So which include unit testing, integration testing. We will look at what is unit testing, integration testing later. So why developers do these testing? Because they are the one who know how internal things are happening. Because they are the one who design and develop, not the end users and QA engineers. The other type of testing is called black box testing. So that is, you don't care about how the internal logic is coded or executed. You are just interested in functionalities. For a given correct input, are we getting correct output? You don't care about what happens inside, whether that particular if condition is executed, whether that particular loop is executed right number of times. That is unit testing. And this is for a given input, according to the functionality, are we getting the correct output or are we getting errors and so on, or wrong output? So that is, those are called black box testing. Without the awareness of the internal structure, we test it. Okay. Any questions? Right. So that is a classification. Right. What is the classification? Glass box or white box testing, black box testing. Now let's look at different testings. Testing is not something we do only once. Throughout the development at different stages, different people do different testing. Why do we need to do a lot of testing? Because software is developed, not manufactured. So other things, of course, they have been manufacturing those things for sometimes hundreds of years, like tire manufacturing, biscuit manufacturing. But every software is unique. You don't develop the same software twice. So therefore, all are new functionalities. So most of these are new functionalities which have never been tested previously. That is why we need to do a lot of comprehensive testing. Right. So these are the different testings we do. Usually we go in this order as well. Unit testing or the module testing, integration testing, system testing, or sometimes we call it functional testing, user acceptance testing, UAT done by the end users, and some other testings like performance testing, usability testing. And there are some other testing also which are not in your syllabus like regression testing. So I have mentioned only the testings when mentioned in your syllabus. So you must know who does this testing, each and every. Is it a black box or glass box? Maybe what is the purpose of particular type of testing? Okay. Right. So let's take one by one. Usually when we develop the software system, the first type of testing we do is unit testing. So this is a glass box testing done by software developers while they develop the system. Okay. Sometimes we call it module testing. So we develop a particular module or functionality or unit and we test that unit as isolated unit. Maybe you test a particular method, test a particular class. This is done by programmers. Usually they can get the help of some programming testing frameworks. So usually you write a method and you write another method to test that method and run it. So these are technical test cases. And these are glass box tests because developer knows what are the methods available. Should it go to the if condition, else condition, and is it really going there? Because maybe you have made some mistakes in the conditions and so on. Right. So that is called what? Unit testing. Testing different units in detail. Different scenarios. Mostly these are code level testing done by software developers. And second type is called integration testing. So you know what is integration is. Integrate means you connect modules. Remember, we are developing different units. Student unit module, registration module, payment module, but then there must be connection between these things. So whether a particular two modules are properly integrated, now can they work together as because ultimately it is one software, though we develop a set of units. So test whether this integration is properly done. So that is called integration testing. Maybe you create a student in the student module and then see whether we can do a registration for that student in the registration module. So then those two modules are properly integrated. And those are again glass box done by developers. Test whether the modules are properly integrated. So when we send proper messages or data, are we getting the proper response from that module? Right. Unit testing, integration testing. So the next one is the most popular type of testing, system testing or the functional testing. It doesn't mean that we don't do the other two. Yes, we do other two also. But this is where the system is comprehensively tested, especially by QA engineers, different testers. So this is where you test different functionalities. To do this, those functionalities must be already developed. So these are black box testing, typically done by QA engineers. And they test and say whether the test case is pass or fail. If fail, they will raise a bug saying that this particular functionality is not working properly. And this is how I tested, and this is the result I got. It's a error, system crash. Okay. This is QA engineer's task. But initially the software developers will do it. But later it is more QA engineers, black box testing, system testing, okay, or functional testing. Now, because this is a little bit more serious stuff, so this is what the QA engineers do. So usually QA engineers are separated from software engineers. QA engineers' task is not developing software. Their task is testing. So because this is mostly done by different set of people than the software developers, you need bit of formal approach. And also, if a particular test is failed, you need to raise a bug and assign to the development teams. For that, you need a proper way of saying how to recreate that particular error bug, because otherwise developers will find it hard to get into that error situation. So therefore, when you are doing system testing, there's a formal process. First task is you write the test case, usually done by QA engineers. So they write it. So that is one of their tasks. Then when they get the release, QA release, they execute the test cases that they have written, documented. And if the test case pass, that is a happy scenario. But if the test case fail, that means you get an error, you get a different result, or system crash. So that is where you need to raise a bug and assign to the development team or the leader of the development team, like tech lead. Tech lead will review the bug and assign it to a respective developer who developed this. Okay, because that person has a better position to fix that. And then they will release the fix, maybe in a later release, saying this particular bug is fixed in this particular release, given to the QA. So then the QA people must retest that test case because that test case failed previously. Now they need to test it again and see whether now the test case is passed. Okay. In a future release. So for the developers will say which functionalities are released included to current release. These new functionalities, these bug fixes. Right. So that is system testing. It's a black box testing. So then there are some other testings like performance testing. Remember, performance is one of the non-functional requirements. Performance, security, user friendliness. අපි හැමතිස්සෙම එකම වචන ටික කියනවාට ෆැමිලියර් වෙන්නේ වචන ටික. Right. Performance testing is to test the performance of the system. Now the functionalities are working, but we have performance expectations. When we submit a particular form, maybe you need to get the response within 10 seconds. You need to get a particular report generated within 15 seconds. And also, usually the performance degrade when there are a lot of people using the system. So that is normally the case in banking applications, supermarket applications. Thousands of people access the system at the same time. So therefore, performance testing is mostly load testing, where you apply high load and test the performance. Okay. We check the response time, memory usages, processor usage. That is also part of the performance. And the usability testing or user friendliness testing. That is to test whether your user interfaces are user friendly, easy to use. Otherwise, end users will not like it. They will say this is a headache to use this. You are not following conventions. You are not following good color themes. Usability testing or user friendliness testing. Right. What is the final type of testing? User acceptance testing. That is done by end users, so the customer. Of course, the quality assurance engineers can help set up the environment and so on, but this is where the end users or the customer decide whether they accept the release or not. So before that, obviously they will test, not comprehensively. They will check the health of the system, the happy scenarios at least, because the QA people have certified that yes, all are working fine, but there can be some expectation issues. That is called user acceptance testing, done by customer or end users, and they will say whether accept or not the release. If they say not accepted, that means there are too many issues in that release. Okay, right. So we went up to deployment. That means planning, requirement analysis, design, development, testing. So we have two more tasks, that is deployment, maintenance, evolution, and review. So now let's look at your syllabus, okay? And see whether, so actually we covered huge area today. I don't know if it's too much for you guys. Okay. Right, so we have covered these things, right? Obviously. Look at these things. We have covered these things. Test case, white box testing, black box testing, unit testing, integration testing, system testing, acceptance testing. Of course, still we have not done the deployment. Logical design versus physical design, but anyway, we need to do a little bit more later. But you know what is logical design, what is physical design, because it's specific to database and so on. We are not much interested here because those things we can cover in other subjects. Okay. Right. Functional requirements versus non-functional requirements. Of course, these things we have already done. Feasibility study, identify the business problems in the current system, suggest alternative solutions, prioritizing the solutions, feasibility check, that is planning. And then acquisition options, right? Remember, off the shelf, custom software, in-house, so outsourcing. So those are also important. Okay. So this is this advantages and disadvantages of off-the-shelf packages. Identify of package capabilities and workflows. Remember this gap analysis. So our requirements versus functionalities provided by the system packages, off-the-shelf packages. And gap, analyze the gap, do some mapping, and maybe you need to do some modifications, changes, especially when you are getting off-the-shelf software. Of course, if you build custom software, you don't have these issues because you develop according to your requirements. Okay. Right. So there are some, for example, these things we will be covering in the next class, like data flow diagram, context diagrams, and that is where you get the second paper major question also. And also these things will be covered in the topics as well. Right. And of course, these things we have not covered yet, deployments and so on. Okay, so deployment is something we do next time. Parallel, pilot, right. Direct phase. Right. So that's it for today. So next class, we will do the deployment and maintenance. Then we move on to software development processes because we skip that. We skip that. That is where we have the waterfall approach, iterative prototyping, this part. So this part actually we have not done yet. That is our next topic. Right. Agile. Okay. Structured versus object oriented. So that we will be discussing after discussing the software development tasks. And then we will move on to how to do these modeling, data flow diagrams, and so on. So therefore, you have two more topics after this topic is done. Okay. And also I have shared you your progress. No, so far we have covered 6 topics out of 30. Okay, now we are in the 7th topic. Actually, software development task. Now we are in the middle, almost at the end. So just keep track of what we are doing also. Okay. So then we need software development methods and system analysis and design modeling. So then this is done. So our next topic is database, then programming, then web development. So then just small topics. These are just 2-day topics. 2 day for one topic. Right. So we are pretty much on target, but you must also be on target, okay? Because